In just a couple of billion years from now, the very star that made life on Earth possible could also be the reason it disappears. That's right. Our Sun, the blazing heart of the solar system, will grow so dangerously hot that it might eventually scorch the planets, erase oceans, and destroy everything we know. But paradoxically, this same destructive power could also breathe life into the farthest, coldest reaches of the solar system, maybe even turning Pluto into a warm, oceanic paradise. So how can the center of our cosmic neighborhood be both a bringer of life and a harbinger of death? Well, in today's deep dive, we're going on a journey through the life of our Sun. From its dramatic birth in a swirling cloud of gas and dust, to its golden years nourishing life on Earth, and finally to its spectacular and terrifying death. Buckle up, because this is the life story of the star that defines our very existence. Age, 1 day old. Let's rewind the cosmic clock to 4.6 billion years ago. At that time, the Milky Way was a busy place, full of stellar explosions, collapsing clouds, and chemical chaos. From the ashes of ancient stars, a massive cloud of gas, dust, and vapor began to swirl and collapse under the pull of gravity. As this enormous cloud contracted, it began spinning, flattening into a massive, rotating disk. In the center of this disk, a dense clump of gas started heating up, forming what astronomers call a protostar, a kind of stellar embryo. This was the earliest version of our Sun. At this stage, the protostar was mostly made of hydrogen and helium, but it didn't shine like our Sun does today. If you could have seen it back then, it would have looked dim and ghostly in space, more like a glowing ember than a blazing fireball. But deep within, immense pressure and heat were building. Over the next 10 million years, the massive outer planets, Jupiter, Saturn, Uranus, and Neptune, began to take shape from the remaining material in the disk, and at the same time, inside the protostar, something extraordinary was happening. Eventually, after about 50 million years, the temperature in the Sun's core reached a tipping point, hot and dense enough for nuclear fusion to begin. Hydrogen atoms began slamming together with such force that they fused into helium, releasing an unimaginable amount of energy in the process. And just like that, our Sun ignited. A true star was born. Age 50 million to 4.6 billion years old. With nuclear fusion in full swing, the young Sun roared into life. It began radiating heat and light into the solar system, with a surface temperature of about 5,500 degrees Celsius, or 10,000 degrees Fahrenheit, and a core temperature that could melt your imagination, around 15 million degrees Celsius, 27 million degrees Fahrenheit. The Sun was now a true force of nature, burning through around 600 billion kilograms of hydrogen every second. The amount of energy released in just 1 second could power all human civilization for hundreds of thousands of years. Over time, rocky planets like Mercury, Venus, Earth, and Mars took shape, orbiting this powerful new beacon of light and warmth. It's this very energy that allowed Earth to become a cradle for life. And just to put things in perspective, our Sun is so large you could fit 1.3 million Earths inside it. If the Sun had been even slightly smaller, it might not have ever reached the core temperatures needed for fusion. It would have become a brown dwarf, dim, cold, and incapable of supporting the kind of planetary system we call home. But it wasn't. It became the perfect size to power a habitable world. This phase, known as the main sequence, is the most stable part of a star's life. Our Sun has been in this phase for about 4.6 billion years now, and it will continue to shine steadily for several billion more. Deep within its core, hydrogen atoms continue to fuse into helium, maintaining a delicate balance known as hydrostatic equilibrium. It's a cosmic tug of war, gravity pulling inward, fusion pushing outward. These two forces keep the sun stable, preventing it from collapsing or exploding. During this time, Earth has flourished. From the rise of single-celled organisms in ancient oceans to the evolution of humans, all of it has been made possible thanks to the consistent warmth and light of our sun. But even the most stable things in the universe eventually change. Age, 5 billion years old and beyond. As the sun continues to burn hydrogen into helium, the balance that once kept it stable begins to shift. The core, filled with more and more helium, grows denser and hotter. And as this happens, the sun's output increases. Slowly but surely, it gets brighter, about 1% every 100 million years. At first, this might not seem like much, but fast forward a few 100 million years, and the impact becomes serious. Within 500 million years, the sun will be about 6% more luminous. This increase in brightness will have devastating consequences for life on Earth. Carbon dioxide in the atmosphere will decrease as the planet warms, making it harder for plants to perform photosynthesis. As plants die off, animals that rely on them will perish too. Eventually, life on land will vanish. The oceans might hold on a little longer, but they too will begin to evaporate as temperatures rise. At around 5.6 billion years, the sun will be 10% brighter than it is today. Earth will become a runaway greenhouse world similar to present-day Venus. Our once blue planet will be a lifeless, scorched desert. The oceans will be gone, the atmosphere stripped away, and the surface too hot for any known life to survive. All of this sets the stage for the sun's final act, its transition into a red giant. Age, 9 to 11 billion years. Eventually, the sun will run out of hydrogen in its core. When that happens, gravity will win the tug of war. The core, no longer supported by the outward push of fusion, will begin to collapse in on itself. As it collapses, it heats up even more, igniting a shell of hydrogen around the core. This causes the sun's outer layers to expand outward. It will swell to hundreds of times its current size, becoming what astronomers call a red giant. The transformation will be dramatic. The sun will become cooler on the surface, taking on a reddish hue, but paradoxically, it will also become vastly more luminous, up to thousands of times brighter than it is today. From Earth, or what's left of it, the sun would dominate the sky. If it hasn't already engulfed our planet, the heat will have baked it beyond recognition. The inner planets, including Mercury and Venus, will be consumed entirely. Earth might follow, its crust vaporize in an inferno of plasma. But while the inner solar system is annihilated, places like Saturn's moon Titan could come to life. Ice will melt. Liquid seas could form. Life might even emerge anew in these once frozen worlds. The red giant phase will last only a few 100 million years, a blink cosmically speaking, but it is one of the most dramatic episodes in a star's life. And it all leads to one violent, blazing event, the helium flash.